All right, so let's talk about representation of functions. So Unit 5, Lesson 7, students will be able to represent functions in many different ways, including tables, graphs, equations, and word phrases. So basically, we're putting together lots of things we've already done. A function rule is an equation that describes the relationship between inputs, the independent variable, and outputs, the dependent variable. Write a function rule for the following. The output is 7 less than the input. So typically we use y for output, is we know equals 7 less than the input. Now remember, this was one of the tricky phrases, 7 less than, because what we need to do is say, how do I get 7 less than something? Like if I wanted 7 less than my age, I would say, okay, how old am I? 7 less than that, I would subtract 7. So it's going to be y equals x minus 7. So 7 less than is one of those tricky phrases. The output is the square of the input. So to square something means using an exponent. The output is square, that's your little 2 up in the corner, x squared. Evaluate each of the rules you wrote when x equals 5. So if we go back up here, y equals x minus 7. If we're going to evaluate that when x equals 5, we're going to do y equals 5 minus 7. And we're going to get that y is negative 2. So if the input is 5, the output is negative 2, and that ordered pair would represent the input and output. So now we're also going to look at y equals x squared. If the input is 5, y equals 5 squared, then y would be, don't forget 5 squared means 5 times 5, which is 25. I don't know why I'm having so much of a problem with my camera focusing. So let's see, y equals 25. If the input is 5, the output is 25. All right, evaluate each of the rules you wrote above when x equals 5. We just did that. The tables, t-charts, and graphs you created earlier in the year are examples of functions. Graph negative 3x plus y equals 1. Sorry, negative 3x plus 1 equals y with the inputs of negative 1, 0, 1, and 2. Input x. So we are going to have inputs of negative 1, 0, 1, and 2. So your outputs, what do you get if you do negative 3 times negative 1 and then add 1? So negative 3 times negative 1 is 3, plus 1, the output would be 4. On the next one, 0. Negative 3 times 0 plus 1. Well, negative 3 times 0 is 0, plus 1 would give us an output of 1. Next one, if I plug in 1, negative 3 times 1 and then plus 1, negative 3 plus 1 would be negative 2. And last but not least, if I had an input of 2, I would do, switch my marker color, negative 3 times 2 plus 1 would be negative 6 plus 1 would be negative 5. Now the reason I switched color is because I'm also going to graph them. And I was thinking it would be easiest to see it if the graph had a variety of colors. So the first coordinate is negative 1, 4. Let's do that in black. That would be left 1, up 1, 2, 3, 4. Then we're going to have the green, 0, 1. So 0 means don't go left or right and go up 1. Then we're going to have 1, negative 2, which is red. So that means go right 1, down 2. And last in yellow, 1, 2, 1, 2, 3, 4, 5. So 2, negative 5. So those coordinates are going to form my graph. And that would be the graph that is representing the equation y equals negative 3x plus 1. As you can see, functions can be represented a number of ways: word phrases, equations, input-output table, mapping diagram, and graph. Up to this point, every graph you've created has been linear. Linear equations create a blank when graphed. Linear functions show a constant rate of change, so they create a straight line. And the great part about that is the word linear has line right in it. Nonlinear functions do not have a constant rate of change, and therefore the graphs of nonlinear functions do not create a line. So nonlinear might be some kind of curve like this. It might be a parabola. It might be something that twists and turns. It also could be something that is called a piecewise graph, where you have chunks that go like sections that are linear, but the overall graph is not a single line. So if we look at the back, does each table below represent a linear or nonlinear function? So basically what that means to us is there a constant rate of change? So the first one is going up by 3. And so if the first one is going up by 3 and down here is going down by 8, the next change in input is going up by 3, where the output is going down by 8. The input is going up by 3. The output is going down by 8. So is it linear or nonlinear? We would say linear because it has a constant rate of change. Then we've got over here the second one. Top one is going up by 2. And the bottom is going up by 9. The input going up by 2, the output going up by 22. That's enough for us to know that it is non-linear. Rate of change is not constant. All right, so now we've got just a few here that we're going to graph the following equations. So each one of these, you can probably get to a point where you're doing some of it in your head, and that's okay, but I would at least start out with one on paper. So this one says y equals x squared plus 1. So we're going to do negative 2 squared plus 1. Negative 2 squared means negative 2 times negative 2. And a negative 2 times a negative 2 is positive 4 plus 1. And that's really important that we're multiplying a negative times a negative, which is why it goes positive. So the output is 5. Negative 1 squared plus 1, negative 1 times negative 1 is positive 1 plus 1, and so the output is 2. All of the ones that are positives and zeros, those are a little bit easier to do in your head. So 0 squared is 0 plus 1 is 1. 1 squared is 1 plus 1 is 2. 2 squared is 4 plus 1 is 5. If I go over to graph that, left 2, up 5. Left 1, up 2. Don't go left or right. Did I do that right? Yeah, 0, 1, 1, 2, 2, 5. All right, so because this one has x squared plus 1, we're going to get what's called a parabola. It's a very particular type of curve. This one opens up, but the x squared means that it curves. It is non-linear. So this one, non-linear. And this is called a parabola. All right, and then we also have x cubed. And on this one, we are going to do x cubed. We're going to cube the number in the input. So for the first one, negative 2 cubed. Now remember that means negative 2 times negative 2 times negative 2. It's an odd amount of negatives. So I'm going to get a negative answer, in this case, negative 8. The second one, negative 1 cubed. 1 times 1 times 1 is 1, but it's an odd amount of negatives, so it is negative 1. 0 cubed is 0. 1 cubed, or 1 times 1 times 1 is 1. And then 2 cubed, 2 times 2 times 2 is 8. This one's going to look interesting. Now, I don't have enough spaces over here. I'm going to have to count by 2s. So this would be like 2, 4, 6, 8. This would be negative 2, negative 4, negative 6, negative 8. So negative 2, negative 8, negative 1, negative 1, 0, 0, 1, 1, and 2, positive 8. So that one is also non-linear because of the cube.